Okay, section 3, chapter 7, crystal structure. Today we're going to talk about the structure of materials and, of course, specifically metals. So solid materials are divided into two distinct classes, uh, crystalline solids and amorphous solids, and we're going to talk in depth about each one of these. So crystalline solids. Crystalline solids are solid particles that are highly ordered in 3 dimensions, and they're referred to as a lattice. The idea of lattice was developed from the internal regularity of the crystal structure, a highly ordered 3-dimensional structure formed by the atoms, ions, or molecules is known as a crystal lattice. Characteristic geometric shapes. We're going to discuss this further in the lecture, what they look like, how they line up, and what kind of geometric shapes that they form. They are bounded by planes or faces that intersect at specific angles. Crystalline solids break or cleave along planar faces. They have sharply defined melting and boiling points. A few examples are sugar, salts, and metals. Amorphous solids. Amorphous solids are solid particles. They're randomly arranged in 3 dimensions. They do not have a sharply defined melting point. Melting takes place over a wide temperature range. Amorphous solids undergo irregular conchoidal breakage. Conchoidal fracture is a smoothly curving fracture surface of a fine-grained materials which have no planar surfaces of eternal weaknesses or planes of separation. That means there's no cleavage. Obsidian is famous for its conchoidal fracture surface. A few examples of amorphous solids are glass, plastic, and rubber. Examples of crystalline faces and amorphous cleavage. The separation of these materials will show angular cleavage in crystalline solids and curved, smooth, and irregular surfaces when cleaved or separated. Amorphous structure versus lattice structure of a crystalline solid. The structure of the glassy solid is irregular and random, while the lattice structure of the crystalline solid is precise, highly ordered, and have characteristic geometric shapes. And there's an example of them. There's glass here on the left, or a glassy solid, and the lattice structure of a crystalline solid, which this could be a metal over here on the right.